If you've been working with artificial intelligence recently, you've probably hit a very specific, incredibly frustrating wall. You write this single, perfectly crafted prompt, you hit enter, and you just kind of cross your fingers, hoping the AI gives you exactly what you need. Honestly, sometimes it feels a bit like a slot machine, right? You either win big or you get this totally unpredictable mess. And relying on just a single, unreliable AI prompt, well, that's simply not going to cut it if we want to build truly powerful, automated tools. Okay, let's dive into this because today we are completely changing that dynamic. We are going to explore how to move away from hoping for a lucky output and shift towards engineering guaranteed results.
To do this, we're relying on a fantastic visual roadmap created by 𝗤𝗲𝗏𝗵𝘁. This infographic breaks down the 5 core patterns for AI agent automation. Think of it as our architect's blueprint for building highly autonomous, complex AI systems. So instead of treating AI as this magical 8-ball, we're going to look at it as a series of interconnected, modular components. By the end of this explainer, you'll see exactly how to string these AI models together to create a really robust, automated ecosystem. So here's our game plan for the explainer. 1. Welcome to AI automation. 2. Sequential and routed patterns. 3. Parallel and orchestrated patterns. 4. The iterative feedback loop. And finally, number 5, 4 core architectural benefits. Part 1, welcome to AI automation. We are officially moving beyond the single prompt. As we make this transition, we're moving from being just casual users of AI to becoming true architects of AI systems. And this quote perfectly captures our main goal here. Build scalable, resilient, and maintainable AI agent systems with a modern, modular architecture. That word right there, modular, is literally everything. We want systems that don't just completely shatter when one tiny piece fails. We want systems that can grow with our needs, and systems we can actually maintain over time without losing our minds. That is exactly why we need these specific patterns in our toolbox.
Part 2, sequential and routed patterns. Let's head to the assembly line.
I actually love thinking of this first pattern as the assembly line of our AI factory. We're setting up structures that act like a highly organized, step-by-step manufacturing process, making sure every piece of data goes exactly where it needs to go when it needs to be there. It's called prompt chaining, which means breaking complex tasks into sequential LLM, or large language model calls, where each step builds on the previous output. Notice the heavy emphasis on sequential there. Instead of asking one AI to write an entire research paper from scratch, you ask the first one to just write an outline. Then the output of that first call becomes the input for the second call, which writes the introduction, and so on. They connect beautifully. Now, what's really interesting here is the structure of step 2, the pass-fail gate. When you chain these calls together, your input goes to LLM call 1. But before it blindly passes along to calls 2 and 3, it hits a gate mechanism. If the output from call 1 is garbage, it fails and hits the exit. Boom, it stops right there. This is an absolute game changer. It allows the system to gracefully exit upon failure rather than pushing bad data forward. It saves you time, it saves computational power, and it completely prevents those wild AI hallucinations from cascading through your entire workflow.
Moving on to our second pattern, which is routing. This is where we route the input to the most relevant LLM call based on intent, context, or other specific criteria. Just picture this LLM call router as a highly efficient traffic cop standing in the middle of a busy intersection. A request comes in, the router looks at it, grasps the context, and directs it to the absolute best destination, whether that's LLM call 1, 2, or 3. If it's a complicated math problem, send it to the math model. If it's creative writing, route it to the creative model. Make sense? Part 3, parallel and orchestrated patterns. Time to build the specialized team. Okay, we are definitely escalating the complexity now. We're putting together what I call the specialized team to perform multiple tasks simultaneously, which saves massive amounts of time. So our third pattern is parallelization. The definition is pretty straightforward. Execute multiple LLM calls in parallel and aggregate the results. In this setup, a single input comes in, but instead of going down one single path, it splits. It hits LLM calls 1, 2, and 3 simultaneously. It's kind of like asking 3 different researchers to look up 3 different statistics at the exact same time. Once they all finish up, their individual outputs pass through an aggregator, which simply stacks them together to give you your final output. But we can take this a step further for sure. We need to compare parallelization with our fourth pattern, which is orchestrator workers. So the crucial point is understanding the difference in how the final output is actually handled. Parallelization uses an aggregator to simply combine or basically stable the results together, Orchestrator workers, on the other hand, uses an orchestrator to intelligently coordinate specialized LLMs and a synthesizer to weave their work into a cohesive, intelligent final output. Honestly, it's the difference between blindly stapling 3 different essays together versus having a professional editor combine them into one seamless, brilliant article.
Let's look at the formal definition of orchestrator workers. An orchestrator decomposes the task and coordinates specialized worker LLMs, then synthesizes the results. This is exactly like hiring a brilliant project manager. You give them a massive, overwhelming goal. The project manager, our orchestrator, breaks that goal down, delegates specific pieces of it to a specialized team of worker LLMs, and when all that work comes back, it synthesizes it into a final, polished masterpiece. This is where AI automation starts to feel truly intelligent.
Part 4, the iterative feedback loop. Say hello to the autonomous editor. This right here represents the most complex pattern in our entire toolbox. I like to call this the autonomous editor, mostly because it closely mimics how human beings actually work, learn, and iterate to improve something until it's perfect. This 5th pattern is the evaluator optimizer. The whole concept is to generate a solution, evaluate it, and iterate with feedback until the output is accepted. Instead of just shrugging and accepting the very first answer an AI gives you, this pattern sets up a continuous, self-correcting loop. It creates, it critiques, and it improves, entirely on its own, without you having to manually prompt it over and over again. Let's walk through the steps of how this actually plays out. First, your input goes to the LLM call generator. It creates a solution. Second, that solution is handed over to an entirely separate AI, the LLM call evaluator. If it meets your criteria, step 3 happens. It's accepted and goes straight to the output. But if it doesn't, and this brilliantly illustrates the true power of this system, step 4 is a rejected plus feedback loop that goes right back to the generator. The evaluator acts exactly like a strict editor, checking a writer's rough draft, pointing out the flaws, and making the generator rewrite it until it is absolutely flawless. And finally, part 5, 4 core architectural benefits. Let's tie it all together. So we've gone through all 5 patterns: chaining, routing, parallelization, orchestrating, and evaluating. When you actually tie these tools together, the architectural benefits are incredibly compelling. First off, your system becomes modular. These patterns act as composable building blocks you can just snap together however you need. Second, it's scalable. You can easily scale your architecture from a super simple task to a wildly complex operation. Third, it's resilient. Because you have elements like those pass-fail gates and feedback loops, you get built-in failure handling. Your system doesn't just crash when things go sideways. And lastly, it's observable. By breaking tasks into specific routed steps, you gain end-to-end visibility and insights. If something goes wrong, you know exactly which node, which worker, or which step dropped the ball.
And that brings us to the ultimate question. We've looked at the assembly line, the traffic cop, the specialized team, and the autonomous editor. So which of these 5 modular patterns will you use to upgrade your next AI project from a single, unpredictable prompt to a highly reliable autonomous system? The toolbox is wide open, the blueprints are right in front of you. Now it's time to start building.